So, here's my talk. Awesome. So this is a talk called JavaScripting All the Things. I will kind of go off script a little bit. I've added some demos since the last time I gave these slides. So, definition of a robot in this particular talk and in general is anywhere where you can interface hardware and software. So it doesn't necessarily have to move, it doesn't necessarily have to, like walking robots and sentient robots and everything. That's like a greater description of the robotics. So the robotics in this table, only one of them moves, but it's still a robot. So, about me, I am a UI engineer at Retail Me Not. I am also an instructor for Girl Develop at Austin. I teach JavaScript, HTML, and CSS, indeed, yay. We are a nonprofit that teach women how to code. And I am an unrepentant JavaScript addict. If I can do it in JavaScript, I'm gonna do it in JavaScript. So I'm going to go over a little bit of a description of the history of JavaScript and how it relates to robotics. In 1995, Brendan Eich wrote JavaScript in 2 weeks. He originally called it LiveScript. It has nothing to do with the language Java. They are actually as different as two programming languages could be, and the communities are as different as two programming communities could be. So he wrote it in 2 weeks, and that makes it seem like it could be a little bit of a slapdash language. It's actually far from it. Most of his decisions were extraordinarily deliberate and hold up to this day. This is what JavaScript was used for in the beginning. It was used to make awesome websites, like the Red Ranger's homepage, which you can barely read that. So yeah, it was used as a decorative element. It wasn't used for anything substantial in the beginning. It was only used to make text flash, make marquees happen, all these fun little tiny things that really didn't matter. Until 2005. It took a whole decade, but then AJAX showed up. AJAX stands for Asynchronous JavaScript and AJAX. That is a misnomer. It should be AJAJ for Asynchronous JavaScript and JSON, because almost no one uses XML anymore. Web apps became a possibility with AJAX because you were able to communicate with the server without refreshing the page. So this definitely made web apps a lot more substantial. And JavaScript was still only used in the browser at this point, though. Nothing outside the browser. And then 2009, it's changed everything for JavaScript and the world, I'd argue, but a lot of people would argue me on that. And that is because in 2009, Ryan Dahl showed up with Node.js, which is a server-side application of JavaScript. Asynchronous non-blocking I/O in a server, really fast or really slow, depending on if you used it for actual web serving or Fibonacci sequences. And so it changed. JS was no longer limited to the browser. Wow, I actually forgot that sentence there. And also V8 is a large part of what made Node possible. It is a JavaScript interpreter, and it actually made JS fast enough to be feasible. This is also the point where the JavaScript community really started to take shape. Before Node.js and arguably between AJAX and Node, there were not many JavaScript developers. There were web developers who happened to yell at /program in /whatever with JavaScript on the side or as part of their job. In 2009, JavaScript developers really started to become their own sort of subclass, where we now have people writing nothing but JavaScript. So 2010 had an event in it that really kind of seemed quiet at the time and really seemed like no big deal, but it actually becomes the linchpin of the JS hardware movement. And what happened was the guy who runs JSConf, Chris Williams, wrote Node serial port. And what this does is allows devices to communicate in Node via the serial port. And in our case, the serial port means the USB ports. Now, the reason this didn't seem like a big deal is it was really difficult to use if you didn't already know a lot about hardware. Yes?
Are these going to be online slides?
Yes. It wasn't easy to use if you didn't already know a ton about hardware. Unless you had an EE degree, Node serial port really didn't help you all that much. So segue back to the timeline. In 2011, Boot to Gecko came out. And what that is it's a phone operating system that runs HTML, CSS, and JavaScript as its needed application language. So if you ever use PhoneGap or Cordova where it uses a web view, this is kind of like that, except you just write HTML, CSS, and JavaScript and put it directly on the phone. This is a Boot to Gecko / Firefox OS phone. So I said that already. So my first demo has actually been running this entire time. This is a Firefox OS phone with a Firefox OS app that I wrote, and it controls via WebSockets my Reveal.js presentation, also written in HTML and CSS and JavaScript. So what it's doing is whenever I hit a button on the phone, it is communicating via WebSocket to the server running on my computer, which is communicating to my browser, which tells it to move the slide. What it also does is, let me go back to a slide with notes. It also sends my notes back to the phone, so I can look at my phone and see the notes for that particular slide on my phone. So yeah, the nifty thing about writing a Firefox OS app, I changed 0 lines of code for this application, served it up statically to my Android device, and it worked just fine. I was able to write it once and run it everywhere.
Can you repeat that? Last part?
Yeah, I was able to write it once and run it everywhere because I statically served it to the phone, changed nothing, and it worked. Because it worked in the browser, just like it works in here. So, 2012. This is really where JavaScript hardware starts to take shape. And like I said, in 2010, Node's serial port came about, and it wasn't really a big deal until Rick Waldron got a hold of it. And what he did was he created a library called Johnny 5. What this does is it's an Arduino wrapper for Node. So you can control Arduino devices, and Arduino is a standard of robotics microcontroller. So there are several different shapes and sizes of Arduino. The most popular, arguably Uno, is, I have a couple of them sitting on this table, and I'll show you them in a minute. And what's really nice about it is you no longer needed to know embedded C to write Arduino. You can now write Arduino sketches in JavaScript, which is awesome for people like me. A lot of people in the Node community went, holy crap, we can now put JS not just on our servers, not just in our browsers, but on our robots. So I'm going to, actually do not follow those instructions. The bot has changed since then. I'm actually going to get it booted up. So what I have here is way too many windows. I mean, text is really small on here. All right. Of course, I'll try to show a demo, and it is not responding well. Oh, no, you've woken up at least. All right, I'm just gonna try to run it. All right, let's try this. All right. Okay, so what this is sorry about the twitchiness of the one on the left. That's actually a known bug in Johnny 5 that I'm actually working to patch. So what I have is, apparently it doesn't like that range. So I'm gonna move it back over here where it doesn't twitch. So what I got is 2 potentiometers. They're like little knobs that turn, and when you turn them, the servos move in reaction to the turning of the potentiometer. So yeah. I'm working on it for a prototype. I had flex sensors, which are long, flat little sensors that go off when you bend them. My cat ate one of them, so I switched to potentiometers since I didn't have enough flex sensors to complete the project after that. He eventually passed it.
Your cat now?
Yeah, somebody joked that I should run wires down there and see it like flexing through his digestive tract. He did eventually pass it, and he was fine, a little expletive. So, but yes, I switched to linear potentiometers. The eventual application of this project is I will buy another flex sensor, and a friend of mine wants to wear a wing with a costume that will expand, and so she'll be able to do that by flexing her fingers. So the sensors will feed into the servos, and then the servos will extend the wing. So, yeah, there's a prototype for that. Or she could possibly use knobs instead. If she has a cat, I'll probably recommend that particular application. So, I'm gonna unplug this and hope it doesn't freak out. All right, So back to my slides. There. So, 2012 and 2013 really also contributed to JavaScript hardware in a more direct way. Tiny, cheap ARM computers become widely available. ARM is describing the processor of the computer. ARM is a very cheaply made but very powerful little processor. Most of your cell phones have ARM processors. And so we're going to talk about two of those. This one's the Raspberry Pi. It's also showing its output on that screen over there. And apparently it just thinks I'm hitting the enter button over and over again. Oh, good. That stopped. So onboard, it's got an ARM processor. It's got onboard RAM. The storage is on an SD card that's sticking out of the side here. And then GPIO pins. So I have a prototyping cape on here right now, but so that's the actual Raspberry Pi. Those are the GPIO pins. They're not very usable on their own, so I got a shield, which kind of plugs in on top and gives me access to the pins in a better way. So this whole setup cost me about $50. It's a Model A, so it was $25 for the actual computer. I spent $15 on the shield. Yeah, it's $40. So actually $40 for the entire setup. Model Bs are $35. So you get this entire dedicated tiny computer for $25 to $35. A lot of education places are starting to use these small computers to teach children because you can easily buy a bunch of them for cheap, and they run Linux. So you can run several different educational programs on them, which is really nice for low-income schools. About 5 seconds, maybe 10 seconds after the Raspberry Pi was released, someone ported Node to work on ARM architectures. So like the first thing someone did was port Node to work on an ARM architecture so that we can have JavaScript on the Raspberry Pi. The implications of this are it's just as if you're running Node on your laptop, but it's on a tiny credit card-sized computer with GPIO pin access. So even better Node robots than with the Arduino. These are commonly used as media systems, Wi-Fi attached sensors, or notification systems. I have a Series A in my home, and so when my phone connects to my home Wi-Fi, it signals the Raspberry Pi, turns all the lights on, and scares the living crap out of my cats. So that's what I have one of mine doing. This other one I'm using to make a picture frame because I couldn't find one that would play cat GIFs at my desk, so I'm making one out of a Raspberry Pi. I want cat GIFs at my desk. You can call my applications of robotics frivolous, but everybody will want one when I finish this thing. The other one I have is the BeagleBone Black. That is this guy. Also credit card sized. To me, it defeats a lot of the limitations of the Raspberry Pi. You have to plug the Raspberry Pi into a display, or SSH into it, but to get it started, you have to plug it into a display. I found that kind of inconvenient, rewiring my TV every time I wanted to use the Raspberry Pi. I SSH into them once I get them set up. The BeagleBone Black actually can, you connect via USB and you can mount it as a disk drive, and actually it's a web server on its own, so you can go to it and code from there. So the other thing it has that the Raspberry Pi does not is, quick definition, analog pin versus digital pin. A digital pin can be on or off. An analog pin can send a range of values. So when you're doing input, you usually want an analog input. You don't. Sometimes you'll just want on/off, but normally you'll want a range, like a temperature sensor or something like that. With output, you want binary is good for like little LEDs. You want them on or off. If you have an RGB LED, you'd want analog because you want different values of red, green, and blue, not just on and off. So the BeagleBone Black has several analog output pins. The Raspberry Pi has none. So if you want to do analog applications, a lot of people will tether an Arduino to their Raspberry Pi and then use those analog outputs. I'll just use the BeagleBone if I want analog outputs, but that's up to you. Oh, it also has the Cloud9 IDE built into it, which is really nice. It's a web-based IDE. So you can edit your JavaScript on there. You can also edit Python on there. It has two native libraries, one in JavaScript and one in Python. I would show you the BeagleBone, but that is why I learned not to firmware flash hardware a day before a talk. It's decided it's not talking to my computer anymore. So I'm gonna have to figure that one out in the next couple days. What's great about, actually, I'm gonna show you one more demo that isn't in my slides. This is an Esperino. And what this is it's a Kickstarter project. Pre-orders are available if you didn't back it. And it is a microcontroller running JS directly. It's not running Node, it's running its own JavaScript interpreter. So that means, unlike the Arduino that has to remain tethered to the computer to run JavaScript, I can write directly to it. So what I'm going to do is I'm going to open up my IDE. And where's the window? There it is. Awesome. So I'm going to actually plug it in. Are you kidding me? Oh, we are not going to play this game. Sorry, I yell at my robots from time to time. Come on. It's right there. It's plugged in. Find it. Well, I was going to show you guys. What's it called again? Espruino.
How do you spell that?
Espruino. Check something. Yeah, it doesn't see it at all. I'm gonna try this. Resetting it real quick. Not frying it by shorting it. This might be a bad connector cable, actually. I've had trouble with this cable in the past. Apparently resetting my computer just sent all my connections back. So, 1 second. So any questions while I'm frantically flailing to set this up again?
How does the Beagle, what is it, Beagle Bone or Beagle?
Yes.
Okay. How does it compare in price to Arduino?
It is, okay, so the Arduinos are $30, but if you want a kit to get yourself started, it's about $100.
Okay.
That also includes all the components you'll need to make a ton of cool stuff. If you're looking for a recommendation, I would recommend the Spark Fun Inventors Kit. That's my personal favorite.
Isn't there one called Adafruit or something?
Yes, Adafruit also sells an introductory kit, and it is pretty good as well. Certainly not to disparage Adafruit. And Adafruit, I swear, I spend like half my paycheck at Adafruit. I'm not even joking.
How much was the Beagle Bone again?
The Beagle Bone, the kit I bought was $80 by itself. I believe it's $35 to $40.
Okay.
You're just not gonna cooperate now that I'm in front of all these people, are you, robot? You're the worst today. Oh, hey. All right. All right, sweet. So I have a program running that actually kind of explains the Espruino. I can't recommend it yet. It's kind of an unfinished project because I'm sending the strip the same values over and over again, and yet it's showing me completely different colors. So it's not quite ready, but it's definitely, if you know C, and mine is super rusty, it's an open source project, so if you want to help write on the interpreter, this is the intended output. So this is an RGB LED system. They're called NeoPixels on the Adafruit website, and they're my best friend because I like playing with colors and lights and stuff. So yeah, that's pretty much the demo right now. Yeah, I think that's all my demos. So I replaced BeagleBone with that. So while I have a lot of stuff on this table, and while most of it is working, and it's all pretty awesome, this isn't even close to everything you can do right now with JavaScript and hardware, because I don't have nearly enough money to purchase all of these things yet. So Nodecopters is another really good one. If you've ever seen those quadcopters you can control with your phone, about 2 weeks after they released those to the public, somebody hacked a Node library together to pilot them. It was really cool. At NodeConf last year, someone wrote something that would take over all of the quadcopters in the immediate area, and he hit a button and all 10 of them took off at the same time and started hovering. It was amazing. So Nodecopters, wireless node bots, someone has figured out how to Bluetooth tether these to your machine. I'd love for them to post that code because I cannot find it. And the second I do, I'll be tweeting it all over the place because it's gonna be awesome. HTML crawlers, a lot of people use Raspberry Pis for things like this, or Bitcoin mining, or lots of things. Distributed systems, you can have several Raspberry Pis networked together. You could have a bunch of BeagleBones networked together. They do have a Wi-Fi expansion like that one. So you can actually leave the BeagleBone running by itself. It will connect to the internet. So these, the BeagleBone and the Raspberry Pi are autonomous machines. As long as they have power, they are autonomous machines, whereas the Arduino and the Espruino are not. They require input from a computer. All right. And the last one is not really a robot, but it's proof of Atwood's law that if you could write it in JavaScript, someone will. Someone implemented Git in JavaScript. So you can use Git in the browser now, which, mind blown. Someone wrote an IDE that actually just basically you can do everything, including Git, in your browser now, which is fantastic. And the moral of this story is it is a fantastic time to be a fan of JavaScript because it's not going anywhere. It's awesome, and you can do a ton of really cool hardware and software projects with it. But the question next is, what can you do to contribute? Build something and anything. I mean it. Dawn Casey, if you've met her, she's Keith Casey's wife. She just started learning software development. We were at a hackathon and they ran out of name tags. So she put her Twitter header on her phone and held it up to her chest as a name badge. She has most of the materials to make that into a robot. She's making a little Wi-Fi enabled thing that will be in her pocket. The wires will run up to the name tag and it will show that same picture as her name tag. And she can also set it to be whatever she wants. So my advice, if you feel like, oh, I want to do this, but I don't know what I'd build, think of something that interests you or something you want but can't find or it's too expensive or something, and just start logging those ideas and thinking, can I build a robot to solve this? My latest idea was, I wanted a picture frame that played GIFs, actually played the GIFs, and I found a bunch that would show the first frame, and I found a bunch that were $400, and neither of those were feasible or what I wanted, so I thought, okay, a Raspberry Pi costs about $25, a display for said Raspberry Pi costs about $15, so $40, picture frame that plays cat GIFs on my desk. So, definitely think of things that you would find convenient. Home automation is a huge field for these kinds of robotics. And then document your build. Doesn't matter if it's a flashing LED, document it. Because someone will find it, someone will use it, and someone will learn from it. Especially if you have problems. It seems kind of reverse intuition, but if you have a problem and you solve it, please document it. So when I Google it later, I'll find your solution. So a good article for a reference on this, and sorry for the language, but it's easily the best article I've read on the subject, is Garen Means wrote an article on her blog called How to Blog About Code and Give Zero Efforts. So what this is about writing blog posts for people who are scared to write blog posts. I started writing because of this article, and I recommend you all do the same because it's fantastic. We need more women voices in tech. We need more of y'all blogging.
Can you scroll up here so we can see the title?
Yes. How to blog about coding, give 0 Fs. So yeah. And actually, all of Garen's blog is really awesome. So if you haven't read it, it's fantastic. So, slides again. Oh, okay. That's what I've got. Any questions, comments, concerns? Yes.
Would you be willing to show us your actual code first?
Yeah, totally. The code for my Johnny 5 example is right here. So, in fact, I'll walk y'all through it. All right, so this is the code for here's my user pointer, for this little guy that does the flexors. So, what I'm doing is finding my laser pointer. So, oh, well, that doesn't show very well. So line 1, I'm just telling Node that I want the Johnny 5 module, and then I'm setting up some preliminary variables. Setting up my board. This is if I have multiple devices plugged in, I need to tell Johnny 5 which device to connect to. So then I'm saying when the board is ready, when I'm connected, when I've got everything I need, I'm setting up a new sensor, 2 new sensors at A0 and A1. And if you look at the board, and I don't fling stuff everywhere, and there's not a bajillion wires here, A0 and A1 are plugged into the 2 potentiometers. So I'm just simply telling it, listen for signals from these 2. And then I'm setting up new servos, which are these dudes, on 10 and 11. So 10 and 11 on the Arduino. So the REPL, oh yeah, REPL's pretty awesome. I should show you that. Let me plug this back in. Not important. So, back to my terminal and turn this on, and I'll show you the REPL, which is pretty cool. Yeah. You're freaking out. I get it. There's a bug in the servo code, and eventually that one should stop panicking. Oh, maybe it's this guy. There we go. Awesome. So, this information is being just console.logged out. So the REPL, what the REPL does is it allows you to access your pins from the command line. So it's really good for debugging if you want to know what a sensor is giving you while you're... there we are. So I gave it sensor, and I can say sensor.value if I can type. What? What's the value? Sorry about this. I haven't done this demo in a bit. All right. So you're not going to give me that. Okay. Okay, it will give me that. Oh, that's tiny. Also, that's way low on the screen. So, I told it I want sensor.raw. Oh, there it goes. Hold on. Swear, I gotta work on. There we go. So sensor.raw, I just simply told the REPL, or REPL stands for read eval print loop, in case. Read eval print loop. So it's reading in the code, it's evaluating it, it's printing out the results, and it's in a loop. So it's telling me that that sensor has a value of 1009. Doesn't mean terribly much, but my application. Okay, I've forgotten the name of it. I did a little bit of math to turn the input from the sensor into 0 to 180 degrees. Why are you sweeping? So I've turned it from 0 to 180 degrees, which is the range of a servo. So just a little bit of math involved, which actually I can show y'all. All right, so on either of the sensors changing, so either the potentiometer is moving, I have it console.log out the value and the raw value. That was so I could debug my scaling function. And then I have a scale input to servo function, which it's just a basic range change function. So yeah, that's the code for this particular, it's only, after you remove all my bogus comments, it's about 20 lines long. And actually the reason I do Johnny 5 as my first example is because this is the most documented example of robotics in JavaScript. Johnny 5 has all of these have code, and all of these have what are called fritzing diagrams. So when I click, please don't be the one example without a fritzing diagram. Aha, yes. Okay, so this is a fritzing diagram. Fritzing is an open source application that allows you to draw circuits. It gives you a ton of components built in, so you don't have to draw anything. And you basically can just map out what you make or follow someone else's mapping. And this is way easier to find out than a photo or a YouTube video, as I had to do the other day. Turns out reading these pins off a YouTube video doesn't always work. But anyway, fritzing diagrams are fantastic, and the reason I'd say if you've never done robotics before with JavaScript and you want to get started, I'd definitely start with Arduino, is because the community has documented this project so well. And yeah, in fact, my coworker has several commits of documentation to this library. So, yeah, any other questions? Sorry, that was like a 20-minute answer to a question, and I kind of got like.
So what is lacking in the framework for the Johnny 5?
You have to remain tethered to the computer. So if I disconnect this, it will just stop working. Doesn't work. That is because of the way it uses the Firmata firmware on Arduino, and that's a message passing firmware. So the message originates from the laptop. So if I disconnect the laptop, there are no more messages and no more robots working. Someone apparently has figured out how to do it via Bluetooth. I haven't been able to find it. I hope they open source it because I'd really like to see that.
Could you just push it to a Pi?
Yes, that is a lot of people's application is you can run Node on the Raspberry Pi, so you can run Johnny 5 on the Raspberry Pi and then use the USB ports sure on this end to connect to the Arduino. Yes, a lot of people do use that to detether, though it's not technically detethering, it's just a smaller tether.
Do you have to do it over USB?
Yes, until the person who claims they got Bluetooth working posts it, which I'd love to see that. Yeah, you have to use USB.
Because otherwise, you know what the YUN is?
Uh-huh.
So that's basically like the two stuck together, so.
Yeah, and also the Galileo.
Yeah.
Yeah. What we're talking about is the Intel Galileo and the Arduino Yun, which is kind of like if a Raspberry Pi and an Arduino had like this awesome little robotics baby. It's basically those two things molded together. So you have a standalone computer with Arduino built into it, which is pretty awesome. And I'm probably going to get a Galileo when my robotics budget resets, which at this rate will be never. It's been way too much fun. I say that, but all of these are actually very reasonably priced on their own. I just have to own all of them for some reason. The most expensive item I have is the Firefox phone. It cost me $150 because I had to order it from Europe. But now they are announcing a $25 phone that they're going to release in the fall, and I'm going to buy it. Probably, to me, it seems like $25 is a good thing to like mount on the wall, and then you have like a touch panel interface for your home, written in web technologies that cost you $25. So yeah, that's going to be really awesome when they deploy those. Yes.
What's been a labor of love for you? Or like what's been your favorite?
Oh man, my favorite.
I'm like favorite child.
Yeah, that actually is. This is like Sophie's Choice over here. Not really. That's actually really rude to the movie Sophie's Choice. Sorry. Esperino has been the most labor of love because I made up a word for it. It's kind of forpy. It doesn't always listen and it doesn't always do exactly what I want. But I'm trying to contribute to the actual JavaScript interpreter, so I'm learning C again, which is when you've been writing JavaScript for 5 years and you try to write C, it hurts. It's actually painful. But yes, the Esperino is the most labor of love thing. The one I'm gonna love the most is when I get the display working on the Raspberry Pi and I have my picture frame. Because I'm gonna be rich, y'all. I'm gonna make a picture frame that plays cat gifs and I'm gonna be rich. And it syncs to Dropbox, and I actually got the Twilio API working. You can text message the picture frame with a link and it will download the picture and put it into the site. Node, y'all. Yeah, any other questions, comments, concerns?
What's the coolest thing built on this framework?
On Johnny 5?
Yeah.
I built a construct that also used flex sensors. It used 4 of them to control an RGB LED. So red, green, blue, and then the 4th one kind of randomized it. So if it was straight, it would not add any randomization, but if you like flexed your pinky, it would just flash random colors for a while. That's kind of, I called it the rainbow glove. So it was kind of fun.
What other kinds of sensors have you used other than flex lights?
Temperature and humidity. I built a thing that lit up different colors. I'm obsessed with light and RGB LEDs. It would light the strip above my bed different colors depending on the weather or the humidity and the temperature. So if I woke up and it was really hot, it would be red and orange and yellow, and it kind of pulsated and looked really cool. It was a nifty wake up.
Today?
Huh?
What was it?
It was it was like white. Like I've never seen it white before. It's been blue, but it's never been white because it was really low humidity and really low temperature. And I was like, oh, this is gonna be a fun day. Like it was white this morning.
So is it pretty accurate? Those sensors.
Yes,
ones, yeah?
as long as you do the math correctly and solder them correctly. And soldering is, I'm terrible at it. My hands are really shaky. I have the principles down, but when your hand is like this, it's kind of difficult to solder. Don't be scared of soldering though. Unless you're really klutzy, and even then, you really have to be really klutzy to hurt yourself with a soldering iron. Yeah, don't be afraid of soldering. I was for a while, and I got used to it now. It's actually really useful. Because otherwise the Esperino wouldn't be working, because I had to solder. It's not meant for prototyping, so I had to solder in the pins, and I had to solder that together because this came with no wires on it. I was like, oh, all right. These are 2 millimeters apart. This is gonna be fun. So, yeah.
Do you have any applications? So like a lot of the applications you talked about there's some input sensor and then a behavior change. Do you have any that actually like log data? from your sensors?
Yes. I had a Raspberry Pi. Well, actually, this was a collaborative one, and somebody else has the actual hardware. We had a weather logging system that would track humidity, temperature, and wind speed, and would graph them on a little web server.
Nice.
Yeah, kept all the information for a week or so, and the SD card would get full, so it would start moving files.
Oh, okay.
Yeah. The cool thing with like the Raspberry Pi is you have access to everything that can run on Linux. So you can run like a level DB or even like MySQL and just use Node to connect to it. And
Nice.
yeah.
That's right.
What's been the biggest pain in the ass? It's like a long list of questions.
Yes.
Answers.
So I started with robotics and JavaScript a year and a half ago, and Johnny 5 was very young, and the Raspberry Pi had just come out, and it was somewhere in between that 10 seconds where someone had ported Node to an ARM architecture. So for me, it's been patience. Just waiting for other people who are really good at C to write some of the things that I wanted to happen. The main reason I backed the Espruino was it worked with RGB LED strips, and I've been having trouble getting that to work with Arduino and with BeagleBone. It worked a little bit with BeagleBone. Yeah, so patience, and patience in general. Things break, and sometimes you break things, and it's really frustrating, but for me, it's just I want to see what I'm building come into fruition, so I'm willing to keep trying at it. Luckily, it's really hard to destroy most of the components on this table. I've only ever fried, the LEDs though, they fry for like no reason. So if you buy LEDs, buy a bunch extra because they fry for no reason. But everything else on this table takes a lot more to break. So even if you wire something the wrong way, that's one thing I notice a lot when especially women come to me and they go, I don't want to break something. It's like, you're not gonna, just build something, go build it, it's fine. Even if you flip everything the wrong way, nothing's gonna set on fire, nothing's gonna explode, you'll be fine. And so, yeah, that's, the most difficult part has been patience in general and patience for the technology to keep advancing. So I'm trying to help now with the Espruino, so.
What's the best way to find different kinds of sensors? Like just a Google search or?
Yes, Adafruit.com has most of the sensors you'll need. They're a little more expensive than other sites, but other sites ship from China and take about 30 to 60 days to actually get you your product. So I'm willing to pay a little extra if I want something within the next 2 months from Adafruit. They have sensor packs as well, which is kind of nice if you want to just like experiment. And then the SparkFun Inventors Kit comes with, I think, 10 different sensors. Okay. So it's a really good starting place if you're looking for trying out new sensors. Yeah.
The Chinese stuff is also like subpar quality.
You know, it's funny. The sensors I've bought from Chinese manufacturers, I've actually never had a dud. Yeah, I was surprised too, because they were much cheaper. So I thought, you get what you pay for. I'm gonna buy this like 40 sensor pack, and maybe 20 of them will work. But it was $8, so all right, I'll do that. They all worked. It was all right, awesome. So
I've had inaccuracies, but not like failure code.
Yeah.
All right, Kevin's saving money.
Right. It just took 2 months for the sensor pack to get here. So it's like I'm paying $8, but they're 2 months later. I actually forgotten I'd ordered it by the time it got there. So I was like, what the heck is this? And all the documentation was in Chinese, so that made it a little more difficult. Yeah. I would definitely recommend Adafruit for like the least inconvenience when you're ordering parts. Or SEEED Studio, they're also called Seed Studio. They do take forever to ship, but all of their stuff's in English, and it's cheaper than Adafruit. So it's a minimal trade-off. We are hiring at Retail Me Not for all levels of engineer, UX designer, visual designer. Talk to me. I have business cards, and if you're looking, it's a fantastic place to work. Like Holly said, we have a brand new balcony on our engineering floor. I was spoiled brat. I actually have a photo of what my office was back before everything froze over. And that is not my office. Where is the one? I don't know if we all see that, but that was my office for 2 Fridays ago, for all Friday. I just sat on the balcony and was chilled. You'll also get to work with the smartest people in Austin, speaker notwithstanding. I work with the smartest people in Austin, hands down. And so it's a challenging, fun environment. You'll write lots of code that will be in front of users within the next couple weeks. And so talk to me if you're looking for new work. All right.
What websites do you use for like project like make team and stuff like that?
I usually come up with an idea for a project and I'll Google fritzing diagrams till I figure out what I want. But recommend it. Make in general. Their stuff's usually pretty good. What was that site called? The Electronics Deals Thread Cutter is actually good for getting deals on some microcontrollers. They had a deal on the Galileo the other day. I missed it. So sad. Adafruit has a ton of documentation tutorials for all of their parts. The only difference is it is in the typical embedded C Arduino, but it's good for wiring diagrams and it's good for overall tutorials for like setting up a Raspberry Pi or a BeagleBone. So yeah. All right. Okay, thank you very much.